Hi, so let's discuss stress strain diagram. So this is part of strength of materials topic. Okay, so ito yung stress strain diagram natin. So for instance, yung x-axis natin represents the strain. Yan. And yung y-axis natin represents the stress, no? So bali yung curve na to, we call it the stress strain diagram. Okay? Itong curve na to. Ulit. So, yung stress strain diagram, so it is parang simple lang siya na diagram, no? But it contains a lot of information with regards sa materials and the design, no? So, for instance, dito, ito yung tinatawag natin na PL, or we call it proportionality limit. So, dito, ito yung nag-o-obey sa Hooke's law, no? That stress is directly proportional to strain. So, yung nangyayari dito, yung material natin, so for instance, yung rubber, no? So, if we applied a force and then release it, so it will return back to its original position. Okay? So, yun yung proportionality limit. So, anyway, the highlight for this one is dito nag-obey yung Hooke's law that stress is directly proportional to strain. Next is itong uh, EL, the elastic limit. So, yung nangyayari dito sa material natin is it undergo the elastic yielding. So, ganun pa rin, no? So, when we applied a force, for instance, yung rubber, we applied a force and then we release the force. So, it goes back to its original position. So, meaning that is under elastic yielding. The next that is itong UYP and the LYP. So, yung YP stands for yielding point. Okay? So, yung nangyayari dito sa material natin under yielding point is plastic yielding, no? So, for instance, yung rubber pa rin. So, if we exert a high amount of force, no? Dun sa rubber. And then, when we release that force, then nakita natin na hindi siya nag-goes back sa original position niya. So, then, yung rubber natin is nag-yield. So, we call it plastic yielding. Or yung paper clip. So, yung paper clip, if you don't apply too much force on a paper clip, so, like, yung parang uh, di talaga siya nag-deform. So, that is elastic yielding, no? Or under pa yan sa PL or EL. Pero when we applied too much force on a paper clip, and then nakita natin na deform na siya, no, because we apply too much force of it. So, deform siya. So, when we release that force, deform pa rin yan. So, meaning yung paper clip undergo a plastic yielding. So, like, uh, when we apply the force and then we release it, it doesn't goes back to its original position. Then, that material undergo the plastic yielding. Okay? So next to the yielding point is the US, the ultimate strength. So ito yung pinaka-maximum na kaya ng uh, material natin. So ito yung pinaka-maximum. So in this case, yung range from yielding point to ultimate strength is medyo nag-harden yung strain natin. Na? Nag-harden. So we call it strain hardening. So, so bali, yung US is yan yung maximum strength na kaya ng material. Okay? So, bali, that also represents the actual behavior of the material. And next to that is the RS. So, the RS stands for uh, rupture strength. So, dito sa RS, dito is nag-break na yung material. Like, nag-fail na yung material. Okay? So, between yung US to RS, yung material natin undergo the nicking. Bali, too much yielding. So, yung material natin is parang nagdi-deform and it forms like a neck. So we call it nicking. So until it breaks. So it's just a short period of time. Like after ma-exceed niya yung US, so matic CRS follow. Okay? So like in a limited time. No? Once mag-deform na kasi yan, so meaning lumiliit yung area na magre-resist ng stress. So kalaunan, mag-fill yung material. So we call it rupture stress. Okay? So ito yung uh, stress strain diagram for steel with defined na yield point. So, sinabing defined yield point kasi meron siyang upper yield point at meron siyang lower yield point. So, most of the time, may mga steel din tayo na wala siyang defined na yield point. So, to solve for the YP or yung yield point, so we take the 0.2% offset. Same slope dito sa proportionality limit natin, which is 1 over E. So, yung E stands for modulus of elasticity, or that is stress over strain, no? According to Hooke's law. So for steel, yung constant na elastic modulus or modulus of elasticity is 200 gigapascal or 200,000 megapascal. In KSI, that is 29,000 KSI. Okay, so yun, no? So if you want to take the yielding point, so we just uh, form a 0.2% offset out of that. Okay. So yung idealized na stress strain diagram natin, so ito yung ginagamit natin sa design. So we have this design curve, yung yellow na part. So yan yun. No? So bali dito sa yielding plateau natin, we have this Fy, the yield stress. And dito sa US, yan yung Fu, no? The ultimate tensile stress. Okay? So yung Fy is the yield stress, yung Fu is the ultimate tensile stress. So ito yung ginagamit natin sa design, especially for structural steel. Okay, so however, for instance, most of the time, yung ginagamit natin is itong sa plastic yielding, yung Fy, no? So for instance, dito sa reinforced concrete, yung mga structure natin, where we use the reinforcing bar, yung ginagamit natin na design curve is ito. Yung green na yan na yung ginagamit natin. No? So like, we don't take the ultimate strength. No? Yung maximum niya is yung Fy. So, yan yung sa rebars natin or yung sa steel reinforcing bars that we use in our concrete structures. So, ano yung significant nito? No? So, meaning, yung ina-allow lang sa atin sa National Structural Code dito sa Pilipinas is we are permitted to use, we are yung maximum na yield stress ng reinforcing bars is hanggang Fy. No? So if for instance, yung Fs natin, yung steel stress natin exceeds the Fy, yung kaya lang ni, yung assume, no? Yung maximum na allowed ng code, which is yung Fy. If ma-exceed yung Fs natin, uh, we should use the Fy, no? Like, Fs is greater than Fy, so yung Fy talaga yung gagamitin natin. Siya yung pinaka-maximum na. Though we know that yung bakal natin is meron pa siyang US, no? Meron pa siyang ultimate strength, no? But we are only allowed at the plastic yielding plateau, no? Di ba? So, hanggang yielding point lang yung binigay sa atin. Though, in actual behavior, yung materials meron pa siyang ultimate strength. So, what significant does it make sa atin as designer, no? So, bale, yung part na yan, yung yielding point dito sa ultimate strength natin, that represents our safety margin. Okay? That represents our safety margin. No? Like, bale, in-assume natin na yung kaya lang ng bakal natin is hanggang Fy, but we know that the actual behavior of our steel as in ultimate strength. No? But we are only allowed to use Fy. That is according to the National Structural Code of the Philippines. So, meaning, meron tayong safety margin. Like, for possible na, di ba? How sure you are that yung bakal na deliver sa'yo is exactly Fy. Di ba? Probably it could be less or it could be more, no? Mas maganda pag more, no? How about uh, less siya, no? So anyway, yung representation dito is you have this safety margin. So, kasi kung ginamit natin yung US sa design, so it's too risky, no? Like, di ba? After pag once ma-exceed yung US, automatic mag-fail yung material. So, it's too risky na wala tayong allowance for that. No? Wala tayong safety margin. So, medyo risky siya. Ganun. Okay? So, anyway, that is ginagamit natin sa mga steel reinforcing bars. Okay, so with respect naman sa energy absorption ng material natin, before that, no, yung nangyayari dito by range is from origin to elastic limit. We have this elastic range, elastic yielding, and then dito sa yielding plateau natin, we have this plastic yielding. So, yung yielding point to ultimate strength. So, yung nangyayari dito is strain hardening. Mali. Parang sobrang stress na yung material mo. So, sobrang lengthy na siya. So, meaning, na-reach na niya na yung ultimate strength niya. And then, dito naman, in between ng US at RS, ito yung nicking. So, medyo na-observe natin na may deformation na nangyayari, no, sa material natin. And we have this failure. Okay? So, pag dumating tayo dito sa RS, meaning failure na yan. With respect sa energy naman, so if we take the area bounded by the stress strain diagram from origin to RS, so we call it modulus of toughness. Okay? So it represents the yung energy na kayang i-absorb ng material natin. So mas lengthy yung stress strain diagram, mas grabe siya mag-absorb ng energy. No? And then dito naman, yung area bounded dito sa origin patungo dito sa elastic limit that represents the modulus of resilience. Again, that is also uh, energy absorption. Okay? Okay, so bali yung nangyayari dito, ito yung sa rebars, di ba? So we have this yielding point and we have this uh, plastic yielding plateau, no? So yung ginagawa natin dito is yung yielding point, yun yung assumed behavior natin. That is our safe side, no? Kumbaga. Though we know we have this actual behavior which is far greater than assumed the behavior, no? Kasi may US pa eh, no? So anyway, yung ginagamit natin sa design is itong FY, no? So yung FY with respect to strain, that is strain Y. Okay? So we have this elastic region and we have this plastic region. So the stress strain behavior of steel consists of two primary regions. We have this elastic and inelastic. So So when we remove a load in the elastic range, the material returns to its original shape, like the paperclip. We don't bend too much. And if we venture into inelastic range, the material will be permanently deformed when the load is removed, like when you really crank on the paperclip. So bali sa design, we really allow our material to yield and okay lang sa atin kahit hindi na siya bumalik sa original shape. Ano? Like, dun sa mga steel bars no, na naka-embed sa mga reinforced concrete beam natin, sa reinforced concrete column natin. It's okay no, na mag-yield sila no, kahit di na sila bumalik sa dating sa original position nila. Okay? That's okay no. We are allowed to use it. Okay? And with respect to energy naman, so ito yan. And so the area under the stress strain curve is the energy the material can absorb. Still follows the high deformation curve. Yan. So yung makikita mo dito, yung medyo lengthy yung stress strain diagram. Yeah, so meaning high deformation behavior yan. More energy it can absorb. Okay. So in situation where we want the structure to dissipate energy such as during earthquake and blast event, may mga blast event and earthquake. So yung magandang materials is itong yung mga high strain na potential, meaning mas lengthy siya no? Sa x-axis, high strain. So after yield is fundamental. Okay? So yielding point natin, so pag ma-reach, after mag-yield siya, so at least may allowance pa siya, no? For CPT, for energy absorption. So okay yun, no? Okay. So unlike dito sa low deformation behavior, which is most likely dito sa mga concrete natin. So, yan, no? So medyo small yung di gaanong lengthy yung ano niya, stress strain diagram. So meaning, maliit lang yung kaya niyang i-absorb na energy na. That's why sa reinforced concrete, nagtutulungan itong bakal tsaka itong concrete. No? So, anyway, the concrete is good for compression and the steel is good for tension. Okay, so I think that's it for stress strain diagram. So, sa next video natin, we're going to discuss the tensile test para alam natin kung uh, saan galing itong stress strain diagram. Okay, so that will be in the next video. Thank you.